Okay, let's get going with the next task, which is port address translation on NAT overload. This is the case where all of the internal addresses over on the left hand side of the network will be translated to a single globally routable IP address, but the way router 2 will keep track of what packet needs to go back to which inside device is by the port number that it assigns to that connection. Okay, let's have a look at this configuration here. So this is going to be configuration on router 2. You see that I just removed the dynamic IPNAT translation command, which is mapping this access list 1 to the pool 1. What I'm going to do now is the command IPNAT inside source. That's our normal beginning, and I either have static or list as my next options. Well, I know it's not static, so it's got to be list, and I want it to be list 1, which is the access list that identifies my internal addresses to be eligible for translation. Now, in the last example, we went directly to pool, which identified the pool of global addresses. In this instance, I'm going to use interface because I'm going to be using just a single interface IP address. And it's going to give me choices of types of interfaces available. I'm going to do gigabit 0/1. And overload. So here we have it. IPNAT inside source list 1. Source list 1 identifies the source address of all of my devices on the inside that are eligible to be translated, and they're going to be translated to the address of interface gigabit 0/1, and I'm going to overload that by using port address translation so that each source port gets identified as a new value, so that packets coming back can be translated to the correct inside address based off of the port destination port of that packet coming back into router 2. So let's have a look at this guy in action. I'm going to say ping 209.165.201.1. So I'm going from R1 to router 3 through my translation router. Let's see what happens. What do I get? Sweet. Okay. That's telling me that I received something that was sourced from 209.165.201.226. Okay, let's go and do the same thing here. 201.1, and you can see no matter which one I go to, it's still always 226. So let's go to router 2 and do a show IPNAT translations. So now we've got some more interesting information. It is telling me that my sequence numbers down here are being translated to the inside global address, but with a different port number here. This is telling me the port number that each reply comes back destined for. And when it comes back destined for these numbers, it knows where to send it to. So in this instance, port number 25192 would have gone back to the router with address .11, and port number 26192 1000 higher goes to the router with the address .10. So we can see the reply coming back from the global internet was destined to the same IP address, but the different port address information enabled the device to send the router to device to send it back to the different routers that initiated those pings. And that is overload. What I would say is that in this command we also have the opportunity to put a pool here. Now this is a less common application of this command. Just using the interface here will give you up to about 4,000 internal addresses that you can support. If you've got more than that, you will want to configure a pool, and each address that you identify in the pool will give you about another block of another 4,000 overloaded addresses that you can use to get more connectivity for more hosts inside your network. Okay, that is pretty much it for port address translation. Let's move on to the next one. Hello, okay, we're back with the final configuration now, and that is port forwarding. Let's just go to our diagram here. So we showed you first of all static NAS translation. That's just translation between a single inside address and a single external address. That's not scalable, not very useful. You saw that when we went to dynamic and port address translation, those are both more useful for getting inside devices, or a large number of them, being able to access external internet places. And those are typically the most common things, overload particularly as it's so efficient in terms of address usage. Those two forms, the dynamic and the port address translation, do on-demand translations and they time out. So what happens if you have a web server or some other resource on your inside network that you want to have addressed, or a connection initiated to it from outside on the global internet? That's where port address translation comes into effect. It's something that complements dynamic and port address translation. You put it in a configuration so that you can have your efficient mechanism of providing internet connectivity to your internal devices addressed on private addressing scheme, and still have an outside device be able to reliably connect to an internal web server or some other resource. So let's go into how we do that. The command here is ipnat inside source, friendly 4 keywords that start our work with address translation. Now I know I'm going to want a static configuration, so static is the keyword I select here. And having a look, now the first option is what we referred to as static NAT, and that's just using the inside address a.b.c.d. In this case, what I'm going to do is do a port forwarding command for telnet. So I know telnet is TCP. What's the next thing I have to do? The inside local address. Let's do 192.168.10.10. That's my router 0. The next question mark is the port number. Well, 23 is what I know for telnet, and the global IP address, I'm going to give it 209.165.201. what does it matter, 50, also to 23, and then we're done. Okay, so this tells me that if I try to telnet to 209.165.201.50, router 2 should translate that to 192.168.10.10. Okay, let's go ahead and try that and see what happens. Router 3, let's do a telnet to 209.165.201.50. Oh, nice. And indeed I am in R0. Let's just have a look at how that is represented in the show IPNet translation. There we are, very straightforward. It's just telling us that I have a static translation between those two addresses and the port numbers that I'm using. 23. Okay, that is all for now. There are some other things we can discuss. There is, for example, the keyword extendable, which allows multiple outside addresses, multiple global addresses to be mapped with port forwarding to a single internal web server. That might happen if you have a merger of companies and they have been using different IP addresses that are resolved to a web server, and you want it all to go to a single internal web server. This is a way of mapping multiple outside addresses to a single inside address, something like that, but I think that's out of the scope of CCNA. But if you're interested, let's have a talk in class, and yeah, I'd be very happy to go through it with you and have some experimentation. So that's all for now. Hope you found it interesting.